we're going to take a look at question 1 on the chapter 4 homework, which is a conversion problem that looks a little bit different because some of what we need to, as an equality, is given in the actual question. So it says in the United States, coffee consumption averages 4.00 times 10 to the 8 cups per day. If each cup contains 135 milligrams of caffeine, how many pounds of caffeine are being consumed each day? So basically what we're trying to convert is this many cups per day to pounds of caffeine. All right, and now one thing I want to clarify here, the cups they're talking about are not measuring cups. It's like a cup of coffee, and I think officially 1 cup of coffee is 6 ounces. But we really don't need to know that to solve the problem because they give us the information to connect cups of coffee to the pounds of caffeine. So when I look at this problem, I do see that they tell me that each cup contains 135 milligrams. So that's an equality. 1 cup of coffee has 135 milligrams of caffeine. And I'm not writing the caffeine here, but remember we're trying to find pounds of caffeine. So let's start the problem like we would any conversion problem by writing down what we're given. So we know we have 4 times 10 to the 8th cups, and it is per day. I'll write it over day. That's what per means, per 1 day. We're not going to have to do anything with that because if you look, they want pounds per day, so that day is just going to stay there. So right off, I see that I can use the information they gave me to cancel out cups. So 135 milligrams of caffeine is in 1 cup of coffee. And so following our units, we see that cups are going to cancel here. And so now if I stopped, I would have milligrams per day so far because I have milligrams on the numerator now and day is still in the denominator. And remember, I mentioned that we're not really going to mess with day. It's just going to stay here. But see, they want it. That's how they wanted it. They want to know per day. All right, so now I'm trying to get to pounds. So I can easily get pounds from, I think, grams. Let's look. I'm going to pull up on my computer, so I don't have it showing for you. Let me log into my computer. I had it all set up, but then it went to sleep. Wake up, computer. All right, so I'm looking at the equality that I gave in class, and I do see the top one in mass it says 1 pound equals 453.6 grams. So I can get to pounds through grams, but currently I have milligrams. So I'm going to use what I know about the relationships between milligrams and grams. And that's going to cancel now. So milligrams are going to cancel. And so now I would have grams per day because I'm not changing that. Now, finally, one more step. So this is going to take 3 steps. I can use the equality that I got from my handout, and I can put 453.6 grams and 1 pound. And so finally, now if I look at my units, the grams are going to cancel, And on the numerator, I have pounds, which is what we wanted, per day. Remember, I told you we were going to have day the whole time. You really, to solve this problem, would not have to write it there. So if you follow through the units, always canceling the numerator with the denominator, we've moved from, on the first step, we took out cups. Then on the second one, we took out milligrams, leaving us with grams. And then finally, we took out grams and left us with pounds. So let me plug it in. So 4.00 times, I have to turn my calculator on first. Okay, 4.00 times 10 to the 8th. And then what you do from there is, we're going to multiply by 135 since it is in the, just a second, I have to clear my calculator. I'm not using the one I normally use, and it is, just a second, let me turn it on. I'm sorry, it's 4.00 times 10 to the 8th. There we go. It was giving me a hard time with my exponents. Okay, back to it. I put the 4.00 times 10 to the 8th times 135 because it's in the numerator, and then on the denominator is the number 1, so I'm not going to do anything. Then on the next one, it would be times 1, then divided by 1,000. And then the last one would be times 1 divided by 453.6. And I get 119047.619 pounds of caffeine for every day. Now, before we plug in my answer, I'm going to plug it in live here. It won't be live if you're watching a recording, but I'm going to plug it in and make sure that I have the right answer. So if I look, first of all, they want it in scientific notation. If I look up here at how my answer is to be entered. And then second of all, I need to think of significant figures. So I go back to the beginning number, which was this one. Oops, I wanted a highlighter, not something to mark it out. Let me see if this is the highlighter. Yeah, this is there. So I see 4.00 times 10 to the 8th, and 4.00 is 3 significant figures. The zeros count because of the decimal. So I want 3 significant figures, 1, 2, 3. So I'm going to drop these 3 digits. So, and that I'm dropping a 0 first, so it's going to keep the number the same. So I have 1, 1, 9, and then 0, 0, 0, and that's pounds per day. And then let's move the decimal so we can have it in scientific notation. 1, 2, 3, 4, 5. So I'm going to type in 1.19 times 10 to the 5th. Okay. I'm not typing it in on our video because that's actually a picture. 10 to the 5th. Submit. And it said it was correct. All right. So hopefully you can look at your example and think about canceling units. That's how we solve these problems, and you can get your answer too. So good luck.